Hi everyone, welcome to our video on solving systems of equations using the Echelon method. So to get started, let's just look at an example of what linear systems are. So a linear system is when we have more than one equation at the same time. So for example, this right here below, let me go ahead. Sometimes they use a brace like that too to show that these two are being worked on at the same time. But this is a system. So there's two variables in this and two equations. So the xy variable and then the two equations as shown. Well, what we need to do is solve these. So what we want to get is an x value and a y value. And there's four different ways that we could solve it. So we will have our choices as we go down the road. The first one is graphing, which is usually a little long. It takes a little bit too much time. So there's other methods that are a little better. And then there's using elimination, or also known as addition, or also kind of more of a just umbrella under the umbrella type term, echelon method. There's also a method called substitution. And then eventually we'll look at a method using matrices and the Gauss-Jordan method. Okay, so, but any of these four can work. And there's three cases that can occur when trying to solve. So there's the one solution case, which we say has a unique solution. So because these are linear, so those are both linear equations, if we were to graph lines, so you could have something like this happen. So here's like equation 1 that got graphed. So we're pretending we know what the exact graph looks like right away. And then maybe the other line does something like this when we graph it. And so right there where they cross is where they have that unique solution. And I'm just labeling it as x comma y. So it's whatever the values are. So maybe it's like 3 and 2. Or 5 and 7, or whatever. So, but this is often the way that we write this. So if they're lines and they intersect anywhere, that is the solution. That's our unique solution. There's a case where we have no solution, which is where we would say the system is inconsistent, and that's when we would have parallel lines. So maybe something like that. So here we've got parallel lines. So these have nothing in common. There's no intersection involved. So that means there's no solution. There's no value that you could plug into both to get the same number equal to the same number. And then our third case is when we have infinitely many solutions, which we would say is a dependent system. And well, let me just go ahead and draw a random line. So infinitely many solutions occur when we have one equation, and then the second equation happens to actually be the same, so it just goes right on top of it. So all of these, so there's an infinite number of them. So because this goes on forever, and you can put as many dots as you want. So all of these are part of the solution. So we have xy there, we have xy there, we have xy there. Okay, so we have an infinite number of solutions in this case. So the equations happen to be the same, and we'll figure that out as we go. So often it's tough to see at the very start, but after a couple steps, we start to see it. Okay, as vocabulary, note that case 1 and 3 are also called consistent systems because they have at least one solution. So these have solutions to them, so the system is consistent. Inconsistent is the no solution case. All right, so those are our breakdowns of the vocabulary. Let's see how we are going to solve a couple of these equations using the echelon method. Okay, so we'll say use the echelon method. Now, when solving these, most of the time, it really doesn't matter what way you do solve it. So if you have a preferred method, you can most likely do it your own method that you want to do. So, and that's what's good about these. We'll have all these choices. So often these problems will be just like, they'll just say solve. And then from there, you choose however way you want to do it. So we're giving you the options, though, to try to figure out which one you like the most. So in this case, we will be doing the echelon method to solve this 2 equation and 2 unknowns. And we have a unique solution case. Again, we won't really know until we start going at it, but at least we can, at least here we should know. All right, so with our echelon case, so this is the true, so they might say write it in the true triangular form. And that's what this one would look like eventually. So eventually our system converts into this. However, we don't really need to do it all the way into this. We can kind of do partial echelon method and still get an answer, and we could save a couple steps. So I'll show you how I'm going to do it. All right, so to use the echelon method, this is also where we are going to use the addition, or they might even call it the elimination method. Okay, so we've got our to addition or elimination method as well. And so what we're going to do is we're going to try to put it in this form. So I want to kind of get rid of this 3x. I want it gone. So the way that we're going to do that is use what's called row operations. So we can do any type of multiplication or division to these two lines, and it will still help us find a solution. So it's not going to really change anything. So for instance, I want to get rid of this first term in this second equation. And the way I can see that is, well, it looks like if I had a multiplier of 4 or negative 4, I could then add the two together. So our first step, we're going to say, let's make row, or let's not even use that vocabulary yet. Let's just say I'm going to multiply this bottom equation by negative 4. And the reason I'm doing that is to get an opposite match to the coefficient of that top one. So I'm not doing anything to that top equation. I'm going to leave it just like this. And then when we multiply everything by negative 4, make sure to do it to every part, we would have negative 12x. And then negative 4, so it's changing the sign, so be extra careful. So times 4 here would be positive 32, and then y. And then this needs to change its sign as well, and it would be a positive 72. Okay, so everything changed signs in that bottom equation because of the multiplying by a negative. And now our next step is to add them. So that's why they might call it the addition method. So addition method because we're adding the two equations together. And they might also call it the elimination because what's going to happen in this step is, well, 12x minus 12x is 0. And we don't really need to show the 0. You can if you want to, but I'm just going to leave it as blank. When we add the y terms together, so negative 5 plus 32 would be 27, and then attach the y, equals 9 plus 72 is 81. Now, if they're being nice, most of the time this goes into them real nice. So 27, when it gets divided on both sides, we would have y equals 3. Okay, so that's part of our answer, so I'm going to cloud it. Now, to put it in the triangular form, so it's not really in triangular form yet. So this is what I mean. We don't really need to go all the way with what they really want, but in case they absolutely want it, the triangular form needs to be rewritten as, so what we did here is, again, I didn't really mess with the first line. I'm going to write it like that. And then the second line, when they did get added, it's going to turn into just 27y equals 81. So it looks like that. And then from here, if they want it in this exact form where x has a blank coefficient, we would divide this one by 12. And then this one is the divide by 3. Okay, so this is only if it's absolutely necessary to do this. Okay, so this is really just kind of scratch work. It's we'll come back to what I clouded in just a second, but if we divide all of those by 12, we would have gotten x minus 5/12 y equals, and then 9 divided by 12, let's go ahead and reduce that to be 3/4. And then dividing this by, oops, I said 3. It really should be 27. Sorry, I was thinking of the answer. So I want just y by itself. So when 27 and 27 divide, it's y equals 3. And then that way it's in this form. Okay, so this is the triangular form, which again is only necessary if they absolutely want it. But what we would do at this point, really, okay, so let's block that off. So continuing with our work here, so we had y equals 3. All we have to do to continue solving it is plug this 3 into one of the equations here. So let's plug y equals 3 into one of the equations. Okay, so and it doesn't matter which one. You could plug them into both to really verify, let's go ahead and just use the top equation. So here's my 12x minus 5y equals 9. So if I plug 3 into the y, we get 12x minus 5 times 3 equals 9. And then we'll continue solving. So we have 12x minus 15 equals 9. We add the 15 over. We'd have 12x equals 24. And then dividing both by 2, or by 12, sorry, we get x is 2. And that's it. Okay, and just to show that it works in the other equation, so if we were to do the 3x minus 8y equals negative 18, plugging 3 in for y, so 3x minus 8 times 3 equals negative 18. And then we'll quickly finish this one off. So 3x minus 24 equals negative 18. Adding the 24 over would give us 3x equals 6. Dividing by 3 is x equals 2. So it shows that the y equals 3 is definitely correct because we got the same answer when we plugged it into both equations. And so our answer, our final answer, should be in the form of a point. So we should just put 2, comma 3. So just make sure to do the x coordinate and then the y coordinate. So we found y first in this case, so don't accidentally switch them. Okay, so x is still always first in the parentheses, y is still always second in our points. Okay, so that's how we could do it. So this is using the echelon method. Now again, the triangular form is only needed is only needed if they really, really want you to do it. Otherwise, I would break it down and do it in quicker steps. So for instance, on this one, I'm not going to do the triangular method. I am just going to use my echelon start and do addition and elimination to help us with it. Now, notice they also are using different letters, so that's no big deal. It's still linear because all of the letters are to the first power. So like x here is to the first and y is to the first. Same deal with this. This is p to the first, q to the first. Anyway, one thing that we do notice is that it's not in the correct form yet. We do want it to be in the form of let's just go ahead and put it over here. So we need the form like ax plus by equals c for each equation. And again, the x and y are different letters than what we have here. That's okay. Let's go ahead and fix it so it is in the correct form. So we've got 8p minus 3 equals q. And then I'm just rewriting it right now to show what we will do. And then they gave us a decimal. That's all right. All right. Well, anyway, so if I want it in this form, it looks like instead of x and y, it is p and q. So let's go ahead and keep the p first. On this equation, so I'm just going to kind of show it real small underneath. It looks like we should subtract the q over. Okay, and then we should also go ahead and add the 3 over. And that looks like it'd put it in the form. So we have our variables on one side. So we'd have 8p minus q equals 3. Now, if this is a little tight or a little tough, you can take it to the side and really make sure that it is working correctly. I often think of these in words, so like I just need to move the q over, which would be subtract, and then I need to move the 3 over, which would be to add in this case. So now it's in the correct form at least. And then this one's almost in the correct form. It looks like all we have to do is just add the 1 to both sides because the p and q are already together on one side. So we have 16p plus 0.5 q equals 1. Okay, and it doesn't matter how you want to eliminate these types of problems. So on this first one, I eliminated the x first. You can eliminate the other variable first or the second one first if you want to. So for instance, like on this problem, because these have opposite signs already, and I know that if I multiply 1/2 or 0.5 by 2, I would get 1. So remember this has a 1 hanging out there, so it is 1q. It looks like if I were to multiply this one, let's multiply by 2, that would make it to where these coefficients are going to match, but they would be opposite. So then from there, it would be easy to add to eliminate. Okay, so I'm not going to mess with that first one at all. And then when we multiply the bottom by 2, make sure to do it to everything. So it's 32p, so 16 times 2. The 1/2 times 2 would give you a positive q, and then times that by 2 would give us 2. Okay, and then now we can add these together. And when we do, we would have 40p. And then the q 0 out. 3 plus 2 is 5. And then one last step would be to divide by 40. And when we do, well, we can reduce that. That would be 1/8. Okay, so there's our p. There's our p value. Now at this point, you could do what we did in the last one and just plug it into one of these equations and continue solving. That would get you the answer. Another way to do it, let's go back to this one. So the 8p minus q. So I'm just rewriting the original one that we wrote above once it was in the correct form. Another way to do this is eliminate the other variable. So again, I could plug that 1/8 in. I could, if I want to, just eliminate the other letter. So in this first one, the first method that I did, or the first elimination that I did was for q. How about we eliminate p? Well, it looks like if I want to eliminate p in this problem, I can multiply both all of the terms in this top one by -2. Because when we do that, let's go ahead and put it to the side, change all the signs, so multiplying by a negative, so it's -16p, and then plus 2q equals -6. And really double check, make sure everything got multiplied correctly. It does look good. And then the bottom one I didn't do anything to. Equals 1. Okay, so everything's still there. But I can now add the two together to get rid of the p values. And so we would have 0, but 2 and 0.5 would add to give us 2.5q. And then -6 and 1 would add to give us -5. And then this does divide nicely. 2.5 goes into 5 2 times. And then while it's still negative in the front, like that. Okay, so there's our answers. And then most likely, again, they would want it in the form of a point. So I'm assuming they want it in alphabetical order. So there's our p value, and then there's our q value as our solution. And with these, if we're doing it by hand like this, so we'll show a calculator method in a little bit, but if we're doing it by hand, you could still always check. So this is the point that I got. If we plug it into our equations, so if I plug it into the first one, 8 times 1/8 minus -2, does that equal 3? Well, yeah, 8 times 1/8 is 1. That would change into plus 2. So 1 plus 2 is 3. So it worked. And then to really verify, I could plug it into the second equation as well. 16 times 1/8 plus 0.5 times -2. Does that equal 1? Well, 16 and 1/8 would become a 2. 0.5 times -2 would become -1, and yes, that does equal 1. So we could really verify our answer with these problems to have no doubt that we got it right. Okay, so we're definitely right on this. Okay, so but that is our solution. Okay, so this is using the echelon method, or at least partially. Again, the triangular form, only if they really ask for it. It's just that extra work that you might need to do. But our main goal is to get the solution. So if you can get the solution quicker is what I would think would be the best. All right, well, that's it for now. We'll show another method in the next video. So if you didn't like this method, hopefully the next one you like a little bit more. All right, for now, that's it. Thanks for watching, and I'll see you again soon.